My name is Terrence Barkin, the Executive Director of the Advanced Carbons Council. Some of you may have known us when we were the Graphene Council and was founded back in 2013, so we've been at this for a decade plus. The Advanced Carbons Council is a global trade association that works with companies like GMG to help promote the use and adoption of graphene and engineered carbon materials. You will have seen that Graphene Manufacturing Group has passed the Verified Graphene Producer program, and I was fortunate enough to personally be on site to inspect the facilities as part of that process. You'll learn an awful lot more about the company now and the products that they're bringing to the market. And with that, Craig, I'm happy to hand over to you to introduce yourself and the company and walk us through what you guys are working on today. So thank you.
Thanks, Terrence, and it's great to be here. I really appreciate the webinar being provided by yourself, and also going through the verification with yourselves at Advanced Carbon Council. Very happy to be one of the few verified graphene producers. Morning, evening, afternoon, everyone. Very pleased to present to you. Thanks for your time. Hopefully we'll have a good and you'll be trusting of the time that you've spent is valuable. We'll go through some questions at the end, and I expect quite a lot, and we'll try to get through as many as we can. We're going to go through this standard investor conversation presentation because we're a public company, so it is best just to keep our messages very clean and always the same. Graphene Manufacturing Group is only a 10-year-old company. We're an Australian-based company, but we're a globally focused and listed on the Toronto Stock Exchange, the OTC, and also Tradegate in Germany. The usual disclaimer for forward-looking statements for high-growth companies such as ourselves. First, start with the problem. What is our products trying to solve? And that's and this has taken some time for us to become aware of, or be able to classify into one slide maybe. And that is it. They're really trying to solve a pretty big problem, and that is trapped heat. Our graphene has always been very good at moving heat, and we've been able to isolate that solution into some pretty mainstream products. And whilst it does other things, and that is definitely the case, we are really trying to trap heat now and move that faster. So when we are moving trapped heat faster, we then have cost and energy savings. We then have time efficiencies gained. We then have equipment life extension, and we then have less emissions quite often. Our graphene, whilst it is graphene, it's also functionalized to be able to transfer heat faster. And then we use it in these various different products. And they're all focused on an energy efficiency and energy storage solution. Energy is the largest physical product market in the world, or after the finance market, it's basically the largest market in the world. And so our products are aimed at the biggest, thing that's happened since the industrialization of this world, and that is the energy transition that we're going through. We believe the energy transition will take decades. There is no single answer. We need many different solutions. And these are the solutions that we believe will significantly help the energy transition on its way. Thermal XR is our air conditioning heat pump coating system, and that is well and truly in the market and also patented in all the major markets. We have G lubricant, which is our engine oil additive, which is also patented now in major markets and is well and truly in the market and being sought out by different distributors in different markets. We also have our additive for lithium-ion batteries, which is called Super G, and that has been tested by some very large companies in that space, and we're working towards hopefully a deal in that space. And then we have our world-leading fastest charging battery. There is the graphene aluminium-ion battery, which charges in 6 minutes repeatedly at very high energy density rates. All of the functions that our graphene is doing here is moving heat. It moves heat in air conditioners, heat pumps, and also data centers. It moves heat in engine oil and lubricates in engine oil. It moves heat in lithium-ion batteries and it definitely moves heat in our fast-charging aluminium-ion battery that we're developing. How do we make our graphene? Well, we've developed our process where this was the first thing we did and was the nucleus, and it is definitely a comparative advantage above all things that we do. It's the core technology of our business, and it was developed over a period of a couple of years where we created this ourselves, where we create natural gas, we created an electric plasma. It's a very small box which enables it to make hydrogen and graphene. It's not a 100% reaction, but we make it to lead the graphene as the master. So we've always had graphene quality as our master, not production efficiency, not production cost or production yield. The graphene powder that we knew was always going to be the quality essence of our business, and hence we've always had that as our focus. The other ways of making graphene, of course, there is mining and processing, and there's a good lot of products that come from that. And there's also now acetylene to graphene, which is obviously, acetylene is obviously made from natural gas. Those form other parts and different functions of the graphene market. There is no one graphene that does it all. We've specialized our graphene into energy markets and heat transfer and ion storage. Whereas other graphenes do other things, and that's the most important thing to know. When we have tried other graphenes, and we have many from other companies, because we are both a graphene producer and a graphene product producer, it hasn't done what we needed it to do. And so what we've often tried to do is even blend some graphene into others, and that has helped. But it is interesting that our graphene remains the predominant, graphene that does the things that we want in these markets, because that is how our graphene came to be, and that is how our markets came to be. It was both a graphene quality and a market-driven outcome. Myself, past energy industry, and many of the other co-founders were also part of the industry, energy industry as well. So it was also what we knew. So whilst it is an efficient way of making graphene and a low-cost way of making graphene, it also makes our graphene the way we want it, and it's also the way we put the electric plasma together, and also helps to become the graphene that we need. We are on track to start up our next gen or Gen 2 graphene production plant at the end of June. Very similar graphene. It'll be up to 20 times higher production rate per unit. It's really not needed for our liquid graphenes. It's really needed for the other graphene products that we're looking at, the bulk graphene Super G, and then also the graphene aluminium-ion battery, which are large percentage graphene products, whereas the other ones are lower percentage products. So this Gen 2 production project, which, as I said, will switch on in a couple of months' time, is the basis for the growth of the company in the Super G and the graphene aluminium-ion battery production space. So we're very much looking forward to announcing that. All intents and purposes, that is going on time and on schedule and on budget. So how are we going in the market? We've already announced that BayRF, basically the largest distributor of coils in the world, and HVAC products in the world, has now offered as under standard pricing at their locations around Australia an opportunity for graphene coating to be applied to all of their chillers at the request of the customer. It's a huge step. We have a guaranteed service offer in time and cost to reply and make this happen right around the country. Australia is a large continent, about the same size, within 1% size of the American USA. So as a result, to be able to provide that, we have, I think, 9 different hubs where we are able to spray our graphene coating onto the BayRF coils. This is absolutely a next-gen step for the HVAC industry. The Thermal XR product will both increase the efficiency of their coils and also provide a 5-year warranty on the coating, which will provide obviously, in the end, we believe a longer life asset for them. As of this date, we're very happy with the rollout, and we'll be continuing to see how we can further this rollout. It's both the first in a kind for graphene and first in kind for the HVAC industry, I would suggest globally. We've also been able to productize, or what we call palletize, our packaging, our products, our 2 products into small packs. So you can see the G lubricant 50 ml and the 500 ml there. They are all 16 languages, including the TXR or thermal XR paints as well. And that's shifted the focus for people onto how they can move the box rather than what is in the box. And it's been a really interesting outcome where we're now well and truly away into distribution space. And I think we aim to have announcements in this space shortly around the distributors that we're bringing on. Now, talking about sales, we've had a number of team join us, and we're now 30% of our team globally is in sales. We have over 10 people in Europe, and now we have around 10 people in Asia through various different parts of Asia, and we have 5 now in Australia. Now, in America, we will be growing that sales team as we are actually bringing on our EPA approvals. So hence why there's little white arrows or green arrows or little dots over on that continent. The rest of the world is currently also being engaged on a number of distribution spaces, and that's really quite engaging. So we've got a number of distributors who are really looking to say how can they distribute for us in the rest of the continents at least, and a number of other large countries. But the space of so far 2026 has been around the expansion of our sales team, and we'll continue to push for that sales team to be larger as we grow, and we focus on deploying our products in as many markets and verticals as we can. The verticals that we are in is quite broad. We are in everyday discussions with many different sectors. It is very challenging to keep up with things, but they keep us honest, and we try to be forthright and clear on what we know in each sector. Now, that is the burden of being a graphene producer, and for the graphene producers on the call, I'm sure they understand that. The market opportunity is immense, and the focus is the most important thing we find. But instill that when you are even focused on the industrialization of graphene lubricants and graphene coatings, even that alone is bewildering in terms of how many applications: electronics, air conditioning, automotive, large B2B vehicles, power stations, energy grid stations, mining and minerals, boats, definitely ships and trains. And that's really just some of them. We are working and have been working with Rio Tinto, and we're very proud to work with them on helping them with their electrification of, or rather their batteries for their large trucks. Obviously, we're in a very early stage with our graphene aluminum battery development, and but they are definitely a thought leader in this space, and we're very happy to be working with them. Let's talk a bit around thermal XR commercialization. There are a number of now industry awards we've received. Probably the most proud is the air conditioning product of the year award for the Australian air conditioning industry. That is obviously a large feature of Australian society, is that we have a lot of air conditioning. 25% of our electricity is used for air conditioning in this country. So to get product of the year award was an achievement. Also, the Singapore Green Building Project. That's very well respected government agency to look at how to use green building products in the built environment, and it's often referred to by a number of countries. And so we have what's called a good rating for our coating, which is a 10% energy saving rating. Hopefully we'll eventually bring that up higher, but a good rating nonetheless is the first one of any type of graphene coating or even a coating to be on that list. We have many different sectors that the coating is well and truly being tried and tested by different companies around the world. Air conditioners is our beachhead. Industrial plants like LNG plants is well and truly progressing as well, and that includes refineries and chemical plants. Heat sinks for electronics is going to be, I think, a pretty large sector by the end, but it just takes time for companies to bring on new space. Data centers probably will be the sector we will be remembered for I think in decades to come. Data centers are quite quickly becoming the biggest power development need for new energy sources, or if not already the biggest draw for new energy sources around the world, and especially in North America. And we can really provide a lot of energy savings and also operating benefits for data centers. And that is going to be, I think, a really big opportunity for us to push through. There's a number of different parties we're involved with there, OEMs and also data center operators and builders. Refrigeration cold chains, I think that's something that will evolve over time. There are a number of companies already we're engaging here, but the opportunity there is quite large because obviously with refrigeration, the compressors basically never turn off. Whereas air conditioning, it can actually come in and out. So the savings are even bigger with refrigeration, but the assets are more, as I say, probably more precious, if I'd say that, and people they generally have a lower risk appetite to move them. So you can see the breadth and the opportunity for just this one coating is quite large, and there are many other sectors that are actually also working on this now, just behind this. So we believe that as we progress, distributors will find this easier to work with because as the applications are conquered and understood, then we'll be able to. The distributors will then be able to come on and be able to resell as early. That way, the technical data and understanding of the products is not needed as much. We have now got an EPA approval through, or consent order through, for our coating in America. It did take probably in total around or more than 2 years. So this enables the product to be brought into America, and it now completes our approvals globally for this product. It will be marketed for air conditioning under the product name of CoolWorks, powered by GMG Graphene, and that is a new Calgon brand. They'll be distributing it through their 4,000 distribution points, and which I can say obviously is a large number of distribution points. So they're what's called a master distributor, and they're already well and truly on the way of many testing spaces for introduction into their big customer value chains. That's obviously America, Canada, Mexico, and the Caribbean. G-Lubricant. So G-Lubricant is probably really only a bit over a year old when we launched it. It has now got official testing done, verified by the University of Queensland, and it is well and truly now being launched in different markets, in different channels, in different packaging sizes and styles. This is our brand, our launch for the G-Lubricant powered by GMG Graphene. But we have got a number of different customers coming to us with all various different requests. It genuinely saves 5 to 10%. It can save 10 to 20% of your fuel. It's just an additive in your engine oil. The graphene is basically at 1 in 10,000 in the total combined fluid, which is obviously a remarkable amount of little graphene. There is 0.01%. That is now patented in all the main markets, and it is, I think, going to be a product that probably will have one of the more greater effects on the world economy, especially with what we've seen is the supply chain risks around energy products such as diesel and gasoline. The graphene product here is a easy to use. It's basically anyone can pour it into their engine or into the bucket or into their packet of oil, or it can be put into large blending runs by big oil companies or even tier 2, tier 3 blenders. So the versatility of supply chain, and that is creating issues because we're trying to work out what is the best way of this to market. And that brings many different options available, and that's always just something to work through. But it does mean, we have to work out what is the best way for this to market, and that is a good problem to have, but it's still a problem. We're actively working with a number of different ways this can get to market. It is a product that I think in the end, as I said, will have a pretty big effect on how people do engine oil lubrication. We understand the science behind it. It is next gen. It is not a simple matter of how it works. We have now got to understand how it works, and it is quite I'd suggest to you that quite next gen type of science, and that is providing us with great comfort on how it works and why it works, and therefore these claims as a public company are out there, and so we're actively working on really the next generation of this product, and that says a lot about how far this has come. We've been working on that product for 8 years, and it comes with an enormous amount of oil knowledge behind it, but then now the next phase is to get it into as many engines as possible. So Super G, which is our additive lithium-ion batteries, has been proven by a number of different customers to be quite a good additive in terms of many different spectrums or parameters for their lithium-ion batteries. Now it does a number of things, and that's why I say good, because it, how does it help? It often increases what's called rate tolerance. You're able to make the battery charge faster and then slower and then faster. So that's what's critically called rate tolerance. It also includes, it does reduce the ability to resist ions in the electrode. And that is really quite something compared to normal graphite. You can see here it's 2.5 times less resistivity than normal graphite and lithium-ion battery. That is a pretty big outcome. We often suggest only 1% in the anode. It can also go in your cathode, and it enables really faster charging lithium-ion batteries. That's what its main benefit is. And when we're able to do that, you're able to then create a new type of lithium-ion battery with very little cost or change to the process of how you make them. And this is not something that happens overnight. And this will be something that we believe will come to the market, and then you'll be able to create these new types of lithium-ion batteries with very little graphene added. Now, of course, we don't use just 1% in our battery, which is our graphene aluminium battery, which we've been developing now for 4 or 5 years. We use almost, in some cases, we use 100% graphene on our electrode, which I've been told is, not very common. But we developed a long time ago, in terms of this development of this product, a way to do basically only graphene electrodes. And then that has effectively enabled us to be able to do this fast charging now for the graphene aluminium battery. So the Super G is basically a part of the graphene aluminium battery, but it is used in a slightly different way. The graphene aluminium battery is now sitting at close to 50 watt-hours per kilogram. We announced the 26 watt-hours per kilogram at 6-minute charging at the end of last year. And now in this month, we announced, actually, no, it's the 1st of May for me. So it's actually last month, we announced the 50 watt hours per kilogram. So that's 6-minute charge time. To get that energy density is quite frankly, basically the one of the largest energy densities at that fast charging time that you can get. The leading high power LTO, lithium titanate oxide batteries, which are obviously, well, they are quite a higher price than normal lithium batteries. That they can operate up to about 37 watt hours per kilogram. And we're going to be coming to the market with a whole lot more cycling testing data showing the different ranges of LTO batteries versus ours. All of the data that we have here is presented by the BIC, the Battery Innovation Center of Indiana, a world-leading battery development business that is both connected with the world-leading universities as well as various different government agencies in America. We've been working with the BIC Indiana for a bit over a year now, maybe close to 2 years. And we are in close collaboration with them to look to go to the next level, which is around scaling our production. And we're finding that a very fruitful endeavor. We have our own battery development lab where we make our batteries in the Southern Hemisphere in Australia, and then we're able to say and ship the materials and find them to work in the BIC Indiana, which means we can transfer the IP successfully and we can get repetitive data, which is also a big test to scale. So it's proving out a number of ways that by having these guys that work with us, it's really proving out that our battery is getting close to the end game, which is obviously getting into production. It's still not there yet, but it's getting close to the final testing stages, which is very exciting because this has been 4 years worth of complete new technology, including complete new electrolyte, complex cathode, and how the battery is assembled. It is a completely new way of assembling it. You cannot assemble this the way a lithium-ion battery is assembled. It has variances which are needed to be managed. We've had to develop every one of those, and it's been quite a journey. But we are almost there, and that's very exciting because it is truly a battery that fulfills a need which really we don't see has currently a battery otherwise being proposed for. We really are focused on these battery industrial B2B batteries, which enable fast charging with a very high safety case, as well as long cycle life. 1,000 cycles, we're aiming for 100,000 cycles. This is a case where the energy density is not really the main driver. It's really how fast these batteries charge is the most important thing. And so when Rio Tinto approached us, when we were working with them on how this battery could work with them, obviously it's going to take a while before it ends up in one of these very large trucks. But one of these large trucks takes about 5 minutes to refuel diesel. And if you were to go to lithium-ion batteries, it'll take about half an hour to re-energize. And so if Rio Tinto was to use lithium-ion batteries in all of their fleet, they would basically have to double their fleet size. And Rio Tinto is a smart operator, and they would not do that. So this is the birth of genesis of this business case. And I believe there's many other business cases out there where in different industries where companies can't really move to lithium-ion just from the sheer fact of how long it takes to charge. There are obviously other ways of getting the batteries in, including robots and swapping over. But we believe this is a strong alternative to the lithium-ion just because of the reason of how fast it charges. And there's a number of good things that come with it that we believe will get there. One is a very flat voltage line, and that is a really flat curve. That is a very useful high nominal voltage. For a start, it's at bit near 3.5 or 3.3 volts, which is basically one of the highest aluminium-ion battery nominal voltages you can get. And that constant voltage during that high power mode is really going to enable our battery developers who take this cell and use it to be able to use it with a consistent power mode, which is it can be a lot easier to use. As if the voltage actually drops during that time, what it means is you need to increase the amps. So that flat battery voltage line is actually quite an asset for batteries, especially in high power modes. The other thing is we can do it in pouch cell or in cylindrical cell. We can really make it in any format we need, but we expect the battery pack to be probably plastic. I don't think it will be needing to be metal. We won't need that for the safety case, and therefore it becomes lighter. We do believe eventually we'll prove that we won't need any cooling. And so that is a good 15-20% of the weight and complexity, and also 5-10% of the energy that you have with a lithium-ion battery we won't need to have. So I think the simplicity of the battery, the ruggedness, material recyclability will mean, and it's really the fast charging case, will mean it'll create its own special niche. It will not replace lithium in any way, but it will add to the batteries available in the world for different applications. You got these various different applications. Diesel engine replacement will be, I think, one of the strong cases. Grid storage is definitely another space with its safety factor. Electric vehicles, I think you use them as a combinatorial type battery where you can take off faster and use regeneration, brake regeneration longer. Vertical takeoff landing for aviation, definitely a high case for that. Rail in terms of safety case, and also ability to charge fast. Personal electronics in terms of being able to fast charge things, I think there will be cases for that to come through, and power tools. But there are other applications that we have in front of us. We have many companies waiting for these batteries or requesting for these batteries. And I think over time, we'll see which one of these pulls harder on our battery case, and then we'll work with them. But the timeline that we have right now, we're still at battery technology readiness level 4, which is where you create and make sure that the electrochemistry is optimized. The next 5, 6, 7, 8 before 9, which is your plant, your large commercial plant. 5, 6 is where you're building the component production factory, and you're making sure that that is scalable, which we currently already have a number of those things worked out. 7, 8 is we are already working in cell process, and it is a very similar to lithium-ion batteries, but there are some variations, as I said. So we see our ability to go through 5, 6, 7, 8 to probably be faster than other technologies out there. If you were to compare us to, say, a solid state battery, that's 5, 6 is you're creating a whole new type of solid state component production process, and 7, 8 you're creating a completely new type of cell process to make. So that's why some batteries take longer to chemistry, like ours, and other batteries will probably take longer to get through factory scale up. They have different problems to get through. We believe our technology, once the electrochemistry is there, and we think we're pretty close, that 5, 6, 7, 8 will be faster, just because of the fact that you're using existing equipment off the shelf. There are 40 companies that make these lithium-ion battery factories already, and we're just adjusting things slightly to our new technology. And so as we go through these next stages, we think that could be probably faster, say, than solid state, definitely. And then you're looking at kind of the last phase there, where we'll be looking at scaling up. The timeline we see is using working various different angles. We have JDA partners already who are interested in the cells, so they'll be seeing the cells this year, and then we'll be looking at scaling up. There are a number of battery plants around the world, unfortunately, that aren't necessarily all occupied. The world is about 3 times more production capacity than the amount of batteries that people make. And so hence, we'll be trying to see if we can use other people's batteries, plants, but also we'll be continuing with our own, also working with potential partners in scale up, because obviously this is a brand new technology and we would love to have scaling partners as we go to the next stage, so which we believe over the next couple of years we should work through that. So looking at our operations, we have a natural gas to graphene plant, and that then leaves hydrogen with some enriched natural gas. Then we have our blending plants, which we have our heat exchange blending plant, our geolubricant blending plant, our pilot plant for Super G, which is in the process of upgrading that. And then we have our battery development center for aluminium-ion battery technology. So what we've effectively got is 5 plants, and as we grow and as we grow around the world, and as we grow for sales, as we expect them to come in, we'll be expanding our production in different areas and in different countries to manage the demand curve. So these plants will probably all be sitting together for some time, but eventually we could see how there'll be a graphene plant in one place and a blend plant in another, and become more separated, a bit like how the oil and gas industry is. At one point there was a lot of plants being put together, and now they're literally separated all over the world. But right now, this is what we have in our warehouse facility in Brisbane, in Richlands. We have all of these plants together. As we then look to expand around the world, we'll be looking to see how we can grow each one of those plants in line with our customer demand. So we are looking at expansion both in Australia, Canada, and America. The opportunity is really focused on de-risking our production profile for our larger customers. And that is a big thing. Big companies do not want to sit at the behest of just one small plant in one country. And then obviously as we grow, we'll be looking at reducing operating costs through mainly focusing on using lower cost natural gas, which really Canada and America are clearly targets for that. And that's one of the reasons why they're there. So, we are now actively focusing on new locations for the expansion of our production facilities, and which is really quite exciting because we believe we're at that space. Now, a quick snapshot of our maturing financial capability. Revenues is building, they are building. We have various different partners. We're working with Rio Tinto publicly with cash, which has been completed, but we are still working with them on that. We do have the grants coming through from R&D, which is quite good for us every year. And then we have a reasonable cash at bank, with us setting ourselves up for the next phase of expansion and good sales growth, which is really all about getting salespeople out to market. So just looking at who we are and what we do, we are a verified graphene producer where we have our own technology and we're growing that, expanding that. We have patents in high margin, high volume applications. We have engine oil additive production, marketing and sales. We have heat transfer anti-corrosion coating, marketing and sales. We are developing, and we have got a new lithium-ion battery additive, and we have a new battery development in graphene aluminium-ion technology. So our layers of who we are, I guess, is growing. That's probably enough for now. We are now in deployment mode, and we're just waiting on the last 2 products really to get full and final product development, so that we can bring them completely to market as well. So just thinking on around what are the highlights here. We have this low cost scalable production technology. We are definitely in a high margin, first to market, global scale sectors. multiple potential revenues opportunities, which we're working through with various different channels and trying to identify the best way to market for these products, which is disruptive products genuinely have disruptive channels, but we've got to make sure that they work. And then energy efficient energy storage market forces, which are obviously on the rise in terms of demand, people wanting to reduce their fuel bill. No one wants to pay more for their fuel, electricity. It's not like you get a better electricity if you pay for more. It's effectively a tax. And that is a driving force for people to look to reduce those bills as the cost goes up, and it's probably not going to go back down as time matures. And then with the potential expansion to North America is now on the cards. That, in fact, concludes the presentation, Terence.
Correct. Thank you very much. Yeah, there's quite a lot of territory, and it's reflected in the questions we have. We're just shy of 40 questions already, and we haven't even started the Q&A period. So we'll jump into that. What I'm going to try to do is blend some of the questions because some of them are related or similar to one another. One of the very first question, or the first question, asked about the verification process. So let me address that one straight off. So the Advanced Carbons Council Verified Graphene Producer program is an in-person facilities inspection where we look at the operation from raw material intake through the production process until the product is ready to go. Or in the case of GMG, where they have blending facilities and other secondary processing of the product, those are also inspected. And then we take a sample of the material from the production stream. It's fully analyzed using the ISO 9651 graphene classification standard on what is and what is not graphene. And while we're on site, we're also looking at health and safety practices, and we're looking at quality control practices. It's the most robust inspection available anywhere on the planet. And GMG passed through that verification, so they are now recognized as a verified graphene producer. It also includes validation of the capacity claims. So basically, do they make what they say they make? Can they make as much as they claim they can make? And it's a third-party supply chain validation. This is very important either for stakeholders, investors, customers, anybody who's evaluating the supply chain. And if anybody has questions about that program and wants to know more, you can reach out to me on that one. Then there were a bunch of questions in here, Craig, talking about, if I generalize it, talking about IP, about patenting, how do you handle that? Questions about expansion, like how do you protect your product going into the Chinese market, again, from a protection point of view. So can you just talk in general about the IP strategy? Some companies take a patent versus a trade secret approach or vice versa. Just talk to us a little bit about the IP and the patenting strategy, if you could.
Yeah, IP is important in this space, but if you go through the big hallmarks of time, it really doesn't also give you any sales. So it is just because nobody buys you because you're patented. So it's just one element, and in the end, famously, Elon Musk gave up all of his patents on the cooling of his batteries for Tesla, and he made them raw brooks, as he said. He was holding back his company because he thought they didn't need they weren't having competition. So I say all this with a caveat that our products are patented generally, and our process is trade secret. I just don't think you can protect a process with a patent. I just think it's pretty much impossible. You could try, but chances are, how do you know that some other countries people don't just use it and say that they're not using it, but meanwhile they are, or they can vary it slightly, and then you have very little chance of knowing how they've varied it. With graphene, I think we all know, really, the people who know graphene on this call, they know every graphene is different, and graphene is very difficult to work with. Once you make the graphene, it's really probably 5% of it. 95% is getting into a product. That's the hardest thing. Yeah. And decade of work, we've had hundreds, probably close to 1,000 easy of different trials of different graphenes and different products. So the effort of actually putting into a product, that is the pace where we patent. the effort of making the graphene, which is moved substantially to where we started to where we are now. That is a trade secret. So it's a combination. It's what's called a downstream patent fence, for those who want to know the exact name for it.
Yeah. Well, for what it's worth, and obviously we've been observing this market for more than a decade, I do think the trade secret route is the more defensible route. And the other aspect of this, at least this is just our opinion, these products are incredibly difficult to reverse engineer. It's hard for somebody to take some of this product and say, what kind of graphene is it at what weight per, and we test product all the time, right? We're testing the materials and we do this destructive testing and analysis for verification. It's a very hard product to reverse engineer. So it does lend itself, I think, more to the trade secret route, certainly. A number of questions were asked about the geographic strategy, which markets are you going to go to? Questions about, why China was maybe not more highlighted on that. I think there's a whole bunch of really good reasons why that's such a challenging market. North America is kind of an obvious one because it's such a large market in a single market, that kind of thing. But maybe can you just talk about, because there's so many geographies, there's a lot of interest in the East, for example, Europe, even though it seems to be a little, let's say, not a buoyant economy, but it's still a very substantial economy. So just take us around the world briefly about, other markets or what markets that you're avoiding for any reason.
Yeah, and it's really just prioritizing. We've got top 22 in the world countries that we're focusing on. And, China is in that, and as well as India. There are just ways and means to get there. We got our first patent up there. Was it 2 weeks ago we announced? So, we got geolubricant up. It's called allowed, which means it's about to be granted, which is great. That was really quite an achievement, I thought. Not really us, but just, to get it through. And I think that, there's how you make the graphene is everything. And then how you make it into the product is the next thing. So it is a full value chain. And then how you apply it, say for instance, the 1 in 100 graphene, that is definitely, so for geolubricant, a really important element as well. So there's any number of things that need to be correct. So you could be, 10 things, critical things, for instance, for something to happen properly. And every one of those things need to happen for it to work. So you need to be in a market where you can control those 10 things for a start. And if you can't control those 10 things, or if you find you have trouble getting those 10 things controlled, doesn't matter what you do. And so we've been in pretty much all the markets over the last 10 years, and Middle East, China, India, and large companies can often not just listen to small companies. And if they don't want to listen, if they don't want to actually learn on how graphene is to be used, then we just move on. There's bigger things. So we work with companies that want to listen, want to learn, and some of them are the biggest companies in the world, and they will sit and learn and listen. But if they don't, graphene bites the hand of anyone who tries to just do it without thinking or learning, and it shows. And in cultures where that is not something people want to take on, it really doesn't mean, it means it's a lot slower to take up. So, we see a great take up in Europe. Because of, okay, how do I do this? And, what do I do? What do I don't do? And America as well. And I think those are the countries that will use it faster because they're more willing to adapt and change and kind of learn. That's what, honestly. And really, there's no other reason why we are where we are. We have people in China. We have people in India, and we've had different people in Middle East as well. But it is you've got to be humble. Graphene humbles you, and I think if anyone's on this call and they've made graphene and that it is very humbling. You cannot think that you know it, and even now we still talk about how you still got to learn from it every day, and that's the most important thing, I think.
Well, we have a couple of other questions to touch on. One was related a little bit to health and safety, and I think it's quite notable, and maybe it's underappreciated. I hope for the audience they really appreciate just how important you getting your EPA approval was for the U.S. market. because nanomaterials are treated as a chemical, so they're regulated under EPA, under the TSCA regulations. And one of the questions is, is there any concern about this nanomaterial kind of getting out into the wild? And the example given was, if you put it in an oil additive and there's a spill, are we worried about it? I'd like to hear what you respond. I do have a comment about that topic,
Yeah,
but what's your perspective?
I think it's a fantastic comment. I mean, it's carbon. So the world has, I think, hyperscaled the fear and risk around nanomaterials. There have been many papers to show that the nanomaterial is pretty much the safety concern as of the same material if it was a micro material. So as in, arsenic nanomaterial is pretty bad, yeah, as well as arsenic. Whereas carbon nanomaterial, well, yeah, sure, but it's carbon. So that's the first thing. What we do is we mechanically, chemically actually insert the graphene into a molecule. And that is really important, that these are not free to roam graphene flakes in G lubricant. As an engine oil marketer and an oil person, I know what's in your engine oil at the end of its life. And it has what's called PCBs and PCAs, which are really not good and cancerous. And our graphene doesn't have that. So what's already in your engine oil are cancerous type additives or carbon, polycyclic aromatics, and they are in all throughout your engine oil. So what we're actually adding at about 100 times less than what's in the engine already, as in soot, is not carcinogenic, and then 100 times less. So from an engine oil point of view, you're talking much safer. You're talking it's isolated inside a molecule. And the thing about carbon, I think, is the most important thing for safety is it is a graphene product. It is a nanomaterial product only when it's been functionalized or dispersed. Usually it's a micron particle because it cannot become unstuck. It loves its to hang. And so, we produce a nanomaterial, but it actually comes out as micron, and you can see it. And if you can see it, it's not a nanomaterial. So majority of our products come out as very large agglomerates. And, that's one of the safest functionalities around graphene. It's actually really hard to make it a nanomaterial. It does not want to be one. And that's one of the things that holds back probably. So there's a few things there. And, obviously saying that if you look up health and safety around graphene, 95% of the papers are around how it's used in medicine, not how it's not, now it's a safety problem.
Yeah, I would echo that. Once graphene is embedded in a host material, it's literally impossible to liberate it without destroying the host material. And as pure carbon, it is pretty benign. So the biggest risk is for a nanomaterial is the inhalation phase. And when you control that, and that's all, people have been dealing with nanomaterials for a long time. There are proven ways to manage and control that environment. But getting your product now, what you're doing is putting this into a product. So it's been productized. It's in a host material. That's going to be the safest form to begin with. The load factor is extremely low, and it's a benign material. So hopefully that answers that question.
Good question, though. Yeah.
There are a couple of questions about the lubrication application. One question, I don't know if this is a sensitive one or not, but if it does anything with the manufacturer's warranty by using this product in the oil product. But the other is also, as you're getting more, and you've got some fantastic results and data on the use of these materials. Are you looking to improve them even further? Right? What's next? What's happening in the development curve?
Yeah. So graphene oil really is. I mean, this bottle here is a really nice base oil, 99%. That is found in the best product engine oils around the world. And a tiny bit of dispersant and graphene. And graphene, as by nature, is carbon. So, that is by the end of it, when putting in engine oil, it's a 0.01% carbon. So, that should be an easy talk with the OEM, shouldn't it? No, of course not. So, you've got carbon already in the engine, you've got soot, it's a process of making the combustion, you have byproducts. And so that's the phase we're in now. We need, and what we're working on is enormous amount of fleet data, so different OEMs can then be clear that there is no harm. And we're working on a number of ways of doing that. And it's a global thing because not everybody believes any other country's work. And so we have to keep working on it in multiple markets. It's just the thing we did in thermal XR. We proved that actually a coating, even though it's infinitesimally thin, it's only 5 microns, our coating can actually improve heat transfer. And that took a while for people to, understand, because most people think a coating will reduce heat transfer, which it does if it's not our coating. Whereas now we need to prove that this does not harm engines, and it doesn't. I put it in my own Audis and no issue, straight immediate energy fuel savings. So, I eat my own dog food, if you do Mark Cuban kind of comment. So it is benign in the fact of, and we know why it works, and we know therefore why it doesn't harm an engine. But that won't stop companies from wanting to get clarity on how it comes to, to affect their equipment. And that's what we do. That's what we're engaging in. That's what we have marketers and salespeople working on. Any help in that space you want to add, anyone online, please come at us. It will get there. As an oil marketer, I think they've seen everything. They've done everything before. It's a 130-year-old industry. So we just got to work through it.
Got it. We are coming up to the end of the hour, so I do want to ask one more question, but I also want to kind of give a summary of what I look at. This is, as the Advanced Carbons Council, we're kind of independent third party. We love all our children equally. If I look at GMG, it's an interesting process for the production, using a gas precursor to turn that into graphene. For those on the call, if you're not that familiar, this is a very well proven type of approach and feedstock, and it results in a very consistent production process for the graphene materials. And I think what GMG does that's a little bit different than maybe some of the other companies is they have this vertical integration and productizing the graphene directly into the lubrications, into the battery materials, into these other products. And even now down to the retail shelf where a customer can go in and buy a branded product off the shelf. That's pretty unique. There are some opportunities, but that's vastly in the minority. The last question I want to ask you, Craig, you've mentioned all these different potential markets with the thermal transport, with HVAC, and with data centers and batteries, and all of them very exciting markets and very important. Which one is the most exciting for you, and which one do you think has the greatest potential?
Like you, I like all my babies. Everyone's a baby to me. I've been on the birth of them, been in there in the delivery room. I think, G lubricant has it's ease in the end, and it is so easy to use, and it is so good for your engine. It reduces your temperature of your engine. It reduces your noise. No doubt eventually we'll talk about it. It prolongs engine oil life, but I don't go out and say that stuff without enormous amount of data. It will save emissions enormous amount. We're getting test data in some countries. It's just astronomical, because the older the buses, the trucks that it goes in, the bigger the emissions reduction it has. And I think that in terms of ease, use, and outcome, it's gonna, I think that'll be the one. Data centers for thermal XR, for the coating, will be where we can really show, some dramatic events. And if you don't have your data center all black, by the end of this decade, I think that you'll be going, you'll be firing your data center engineer. So that's this space. I think that'll really be clear. Air conditioning companies will always think that, they can do it differently. Yeah. We are working on air conditioning, and we've already put a patent in this, which is basically having an air conditioner without fans. So basically using our coating only and no fans. That will take a while to come through, but that is something that could come eventually to the market. But I think heat transfer is a kind of a bit of an unknown science. the market, it's a bit obscure. I think people all want their air conditioner to work. No one really actually understands it, how it magically moves heat from one room to another, but they all expect it to work forever and at no cost. And so that market is a bit harder to kind of change. And anyways, we'll get there. So Thermal XR on your coils. You heard it here first. Fanless, go fanless. I think eventually we'll be out as well.
Thank you, Craig. Just for everybody on the call, if we didn't get to your question, it's just because we had so many of them. We did capture those, so we'll have that, and we'll hopefully be able to follow up with you directly if your identification is given and your email is there. If you have any questions, please reach out to Craig and his team at GMG. If you have questions in general about the advanced carbons market or anything that we do at the Advanced Carbons Council, you can reach out to us. You'll be getting an email from us with a link to the recording and to the slides that were presented today. We always appreciate your time, and we hope that you found this useful and informative for you. Thank you all for joining. Craig, thank you so much, and congratulations on all the progress. It really is impressive. Thank you.
Thanks, Terence, and great to work with you all these years. Thanks, mate.
Cheers.